We come now to thermal physics, and this is the first presentation in the series. We're looking at ideal gases and we're considering three gas laws. And the three gas laws we're going to look at are Boyle's law, Charles' law and the gas pressure law. Let's look at Boyle's law first of all. Boyle's law says that at a constant temperature the pressure of a gas will be inversely proportional to its volume. So what does that mean? If you increase the pressure of the gas, you will decrease the volume. That's what inversely proportional means. If we plot a graph of pressure against volume, that's the shape of the curve, and we might note that as the temperature increases, if you were to plot that graph again, it would get further away from the origin. So we could plot a graph of pressure against 1 over volume. And that will give us a straight line graph. And we might note that as the temperature increases, the gradient of that graph will increase. Let's look at Charles' law. Charles' law says that at a constant pressure, the volume of a gas is directly proportional to its absolute temperature. And absolute temperature is measured in Kelvin. So there we have a straight line graph which passes through the origin if we plot volume against temperature on the Kelvin scale. So what is the Kelvin scale and what's absolute temperature? Well, it's just a scale of temperature. The lowest possible temperature is called absolute zero. It's written as 0 Kelvin. Please note that you don't put 0 degrees Kelvin. We don't talk about degrees when we're talking in the Kelvin scale. It's just simply 0 Kelvin. But 0 Kelvin is approximately equal to minus 273 degrees Celsius, so it's a very cold temperature. Other than that, the scales are pretty similar, so for 1 degree Celsius increment, that would also be equivalent to a 1 Kelvin increment. Let's look at Charles' law graph on a Celsius scale, and you can see there volume against temperature on a Celsius scale. You can see that absolute zero is marked at the point where the temperature is minus 273 degrees Celsius. Let's look at what happens if we increase the pressure. Well, if we have volume plotted against temperature, but we start doing experiments in which we gradually increase the pressure each time, then the gradient of that graph will become less steep. It's moving on now to discuss the pressure law. And the pressure law says that at constant volume, the pressure of a gas is proportional to its absolute temperature. So again, we have pressure plotted against absolute temperature, and we have a straight line graph. And if you were to conduct a different experiment with a volume increased this time, then we could see that pressure plotted against temperature would actually have a less steep gradient if you were increasing the volume of the gas. Now, to remember all these different laws, essentially keeping one variable constant, so you've got pressure, you've got temperature and you've got volume, and out of each of those three variables, each time you are keeping one thing constant, and the laws define the relationship between the other two constants. This is a little way of remembering them. I'm going to show you how to use this in practice because it's very difficult to do this as part of a presentation. But for now, if you just memorise this triangle and you start at the apex of the triangle and you remember the mnemonic, can these guys possibly be violinists? And I'll show you how to work with that mnemonic and remember all of those gas laws. And that is the end of part 1 of thermal physics.
Created using Powtoon.